Hello, ladies and gentlemen. In this video, we're going to talk about something called the product property of powers. And this is going to answer the question, what happens, Mr. Grapp, when I multiply two powers together? Well, if they have different bases, like, for example, x squared times y squared, truthfully, nothing. We just keep it as it is. We might move them closer together, like that. But other than that, there's really nothing else we can do to simplify that expression. But supposing they have the same base, they're both x, they're both y, they're both p, whatever it is. If two powers have the same base and we are multiplying them, all we do is we keep the base the same and add their exponents together. Supposing they have coefficients, then we would multiply the coefficients, keep the base the same, and once again, just add the exponents together. What would that look like in practice, Mr. Grapp? Well, let's say I have x to the fourth times x to the third. They have the same base. So, I'm going to add their exponents together. What's 4 plus 3? 7. So I'd end up with x to the 7th power. Box my answer and call it a day. See, we're not trying to find out what x is yet. All we're trying to do here is simplify the expression. I don't like having more than one term. It makes things messy. So we're trying to condense them, consolidate them. And the way we do that with the product property is, if they're multiplying and their bases are the same, keep the base, add the exponents. Okay, Mr. Grapp, I get it. That's pretty straightforward. I could do that in my sleep, honestly. But how do I know you're not just blowing hot smoke here? How do I know this is actually what's happening in math? Well, we can find out by writing it in expanded form. What's x to the fourth? Well, x to the fourth is just x times x times x times x. What's x to the third? Well, x to the third is just x times x times x. And I'm multiplying them together, so I'll put another dot in the middle. Well, what do we have here? Well, we have an exponent written in expanded form. Or sorry, a power written in expanded form. And what power is this written in expanded form? Well, this power is x to the 1, 2, 3, 4, 5, 6, 7th power. And uncoincidentally, that's what we just simplified it into. See, we could use the expanded form every single time, but you know what that takes? It takes time. It takes paper. It takes ink. And as mathematicians, we like to conserve our time, our paper, our ink, our pens, our pencils, and all sorts of calculations can bog the brain down. So we like to use these rules. Here, let's do one with coefficients. If I were to try and combine these powers using the product property, what I would need to do is first multiply the coefficients. So 2 times 3 is 6. And then I just add the exponents. So it becomes 6x, because we keep the space the same, to the 5 plus 3, 8th power. Once again, I'm not trying to solve for x. I'm just trying to simplify the expression. And so that's my final answer. And I can prove to you this is what happens. 2 times x to the 5th is just 2 times x times x times x times x times x. And 3 times x to the 3rd is just 3 times x times x times x. Put a little multiplication in between them because that's what's happening. And then with a clever bit of algebra, meaning just rearranging my expression, I end up just getting 2 times 3 times x times x times x times x times x. That's the first 5. And then 1, 2, 3 times x times x times tex. Times tex. And then I can simplify it. What's 2 times 3? Well, Mr. Grapp, that's 6. And what's this power written in condensed form? Well, that's x to the 1, 2, 3, 4, 5, 6, 7, 8th power. Uncoincidentally, the same thing we got up here. Mr. Grapp, I get it. I trust you. Okay, I understand you're not trying to lie to me. I know. I just want you to realize we're not just making up rules willy-nilly. There's a reason for our madness. The rules just make it a lot simpler. Okay? So let's try and apply this rule to these guys down here. You weren't supposed to see that. Let's say I wanted to multiply these two powers together. Well, just like before, the first thing I need to do is multiply their coefficients. But wait a minute, Mr. Grapp. This x to the fourth doesn't have a coefficient. Well, maybe not on the surface, but remember, if we have just a variable, every variable will have a coefficient, even if it's not there. If you don't see one, how many x's are there? Well, there's one x I can see, and so my coefficient is 1 times x to the fourth power. Now I have a coefficient to multiply. We're doing that in blue, aren't we? So what's 5 times 1? 5 times 1 is just, well, 5. Keep the base the same. And now add the exponents. 7 plus 4. 7 plus 4 is 11. And there we go. Simplified. Box it. Ship it out. Here, why don't you try this last one on your own? And let's see if we get the same answer. Okay. 4 times 2. Got to multiply those coefficients. 4 times 2 is 8. Going to keep the base the same, so 8x. And then, hold on, Mr. Grapp. There's no exponent to multiply. Or, sorry, exponent to add. Well, it's just like before. If I have a variable with no coefficient, my coefficient is 1. In the same way, if I have a variable with no exponent, well, my exponent is also 1. Because after all, x to the first power is just x. So it makes sense. There is an invisible 1. Those guys are so good at hiding. It's because they're so skinny. What's 1 plus 1? 1 plus 1 is 2. And so, 8 times x to the second power, or 8x squared, is our simplified answer. All right, folks. That's going to wrap it up for the product property. It's pretty straightforward. You just, if they have the same base, add the exponents. If they have the same base and a coefficients, multiply the coefficients, and then add the exponents. If they have different bases, well, you would still multiply the coefficients, but you wouldn't do anything to their exponents. They just stay the same. All right, folks. That's going to wrap it up. In the next video, we're going to tackle what happens when we divide by similar exponents. I'll see you there.